In the previous example, we observed the changes of volume and temperature when heat was provided to the piston container kept at 1 atmosphere. The change of phases can be easily reported in that temperature-volume diagram. We'll call it TV diagram, with the saturation temperature to be 100 degrees Celsius under this atmospheric pressure. And we call the resulting line an isobar, from the Greek iso, same, bar, pressure. Let's now consider the same experiment conducted at 2 atmosphere. It is first important to remember that at 2 atmosphere, water boils at a higher temperature than 100 degrees Celsius. In fact, it's been reported that water boils at a saturated temperature of 120 degrees Celsius at 2 bars. Apart from this important difference, we can expect the liquid water to behave similarly than in the previous example. However, the volume of saturated liquid and vapor will also be slightly different, as demonstrated in this new graph. In the same manner, a number of isobaric lines could be produced, all identifying different saturated temperatures on the y-axis and saturated volumes on the x-axis. So here we've got an example at 10 atmosphere, 50 atmosphere, and 150 atmospheres. If we join all the saturated liquid and vapor points together, we end up with a skewed bell curve on that TV diagram. This is what is called the phase diagram at the end. Note that at very high pressure and temperature, we obtain a peak, and that indicates the critical point of the substance here of water. For water, it occurs at 221 bar and 374 Celsius. This is a special state of matter above which no combination of pressure and volume can indeed liquefy the water. If we now draw a line through the middle of the bell curve, we will obtain on the left side of the diagram the saturated liquid line, indicating the temperature and volume combination at which saturated liquid exists. On the right side of the bell curve, we can read the saturated vapor line. We now also know that the left-hand side of the diagram indicates the presence of the liquid phase, and on the right-hand side of the line, we have the superheated vapor. And the mixture of saturated vapor and liquid at the equilibrium could be found under the curve.